Okay, let's get the explanation.
So basically, like what I'm trying to do is
Loud.
basically what I'm trying to do is like we're trying to make a place an investment 10 years, right, at the rate of 6%. So basically we have to pay every month a certain amount that we are investing every month. So on 10 years period, the first year we decided to invest $100, 150, 180, etc. Louder? Okay, so like we're basically trying to make an investment on 10 years. So every month we're going to pay a certain amount, not a fixed amount, but a different amount. So what I did is like on the 10 years, for the first year we're going to pay like $100. The second year, $150. The following year will be $180. So so at the end of the 10 years, we're going to have the future of the sum up of the future value of all the payment we made. So the net present value is like this amount we like investing today, like $100. What's the present value? So according to the formula, the present value equals the future value, factor of 1 plus the rate to the power of negative whatever, the period. So if we get the present value of all those amount that we pay, if we sum up, that will be our net present value. It's basically like an average, like we're trying to sum up the present value to get like this a fixed amount that we're going to invest. Like we have several payment, $150, $180. What will be like an amount that we will invest today so that we can get the future value. So what we have to do is that to get the present value of all those amount, make the an average of those present value so that the average placed at a certain date, a certain rate will get the future value. Do you, like, does it make sense?
Analyst, did he make any mistake?
I'm not sure.
Lina, did he make any mistake? I asked you to graph it, right?
Yes.
So, what did we have here? We have flows. Here, we put money in such a way that these particular deposits are growing. Right? That's why we put it in red, comes out of your pocket. Then, after a given period, you get your money out. And we want to find out what? I'm listening it again. We want to find out what? What is net present value?
Like the average amount.
No, it's not the average.
No, I mean the sum.
The average is a statistical concept. 2 weeks from now, we're going to talk about average.
Okay, so the sum of
Good. It is a sum. It is a sum. Greek capital sigma, sum. You sum up what and how.
by determine the present value of A.
What do you sum and when do you sum?
The present value of those cash flows.
Good. You have future flows, either outflows or inflows. You sum them up at what point of your time horizon? At what point of your time horizon you sum up this information? Good. According to the book, you sum up everything at the beginning. At the beginning, you sum whatever you have there. Clear? And you sum up everything, outflows and inflows at the beginning. The book doesn't say anything more. And no other textbook says anything more. If I will say that he did that, and the year today is 2019, right? He started at 2015. 16, 17, 18, 19, and now is in 2019. Can you tell me what would be the present value, not at 2015, but at 2019? Is it going to be the same or not? Can you be able to tell me what that value would be at 2019? Can you do it? To tell me how you would evaluate the value of these flows, not in 2015, but in 2019. Vanessa is smiling. Can you do it? Who can do it? Can you evaluate this value not on 2015 but 2019? What do you do?
The value of what? Those cash flows?
Yeah, those cash
From 2015 to 2019?
No, all the cash flows, 100, 150, 180, 200, 250, 350, 360, 380, 400. How much is this? Let's say 3,000. Can you evaluate how much this investment plan may be not in 2015 but in 2019?
So that means like our new 2019 we have a reference, like we have to
Correct.
2019.
That's the reference or the base of your calculation. Why we need to do that, and there is no textbook to give that example, but this is what you really need to do. Example, I started putting money for my retirement when I started working. Since then, 30 years passed. Now, I need to reevaluate what is going to happen for my retirement. 10 years before, we had the recession. I lost a lot of money for that recession. Now I recover the money that I lost. And in my 62, I want to see what is going to happen when I'm going to be 72. As time changes, you want to reevaluate the value of what is happening with your cash flows. Can you do it? Good. Don't do it. Can anybody else be able to do it? What do you really need to do? What you really need to do. If you know how to do it, then you know the chapter 2. Present value, future value. Do you know what is on page 45? Or if you have the big book, on 32, 33. Page 45 in the book is what? Page 45 in your book is what? Or page 33 in the big book is what? In that page says you have a period of 3 years. If you have $100 here, and if the return rate, the interest rate is 6%, you will have $83 here. The return is 6%. And Victor, who is not member of the class, is in. That's okay, man. You didn't miss anything, and whatever you missed, we taped it. Can you tell me how to use this idea to give me an answer to this problem? What this idea says. If you are at the beginning of the period and you want to go to the third period, your money grows. If you want to look at the future and you want to see what is happening here, your money discounts. Is this in your page? Can you use this idea to solve this problem that we have here? The problem we have here is you deposit some money. That's not an annuity because it's not the same amount. As the time goes on, you're able to put more money. At the end of the period, you get your reward. I ask you to tell me what is the net present value. The book says the net present value is at the beginning of the period. The beginning of the period is 2015. But as time comes, now we are in 2019. In 2019, we need to reevaluate all the plan that we had and find out what is the value at today. But today is different than yesterday when we assume today. So what happens? The base of my calculation changes. As the base of the calculation changes, can you tell me what to do in order to evaluate the information here? Analyze. I gave you the answer. You use whatever you have here.
So it's like, can you use it, what do you call it, the formula when you're discounting? Like, can you take the 3,000 as a future value?
You ask a question. I ask a question. I want an answer. Can you use whatever you have on page 45? I put it on the blackboard. So you can tell me what is happening with the problem that you have. Do you know why I'm going to give you open books and open notes test? Because the questions are not in the books. The questions in real life. And you need to use whatever you learn in the book to find out the problem in real life. And in real life is that time is moving. And as time is moving, you need to reevaluate whatever is happening. So what do you do here, Lena?
I would have said
Hmm?
something. I would have said something similar, like where did you trying to discount for 6 years instead of
Correct.
10?
Correct. So Lena will bring this value here, and this value here, and this value here, and this value here, and this value here. And these values are outflows. That's why she put them in red. This is what she paid. She will pay in the future, and she counts in 2019 what is the future money. Then she takes this particular flow and finds out what she is going to take today in the future. Which means we dealt with that range of time. How do we deal with the previous periods? How do we deal with the previous periods? Do we discount them or do we compound them? Look at the graph there. We compound them. So what do? We compound, which means the value increases. We take this part, I'm gonna still put it in red because we paid. We take this part here and we bring it here. We take this part here and we bring it here, and we take this part here and we bring it here. And then we sum up everything at that particular point, which means the summation, as the time is coming up, is different in value whenever the rate is the same. And I'll keep the rate as 6%. Is this clear? Now, I want to look at the formula that my buddy put there. I clean up everything that I have, and I look at the formula. And I would like you to tell me if the formula is correct. I want you to tell me if the formula is correct. Or, before Victor starts writing, I would ask Victor to rewrite that formula, not having a multiplication, but having a division. Can you, Victor, rewrite the formula not as a multiplication, but as a division? Or I'll ask the question in different ways. What is happening if you have a power to the negative exponent? What is happening if the power has negative exponent? He put there negative exponent. Why negative exponent? Vanessa, did you take math 051, 056, 206? Good, you took 051, 056 anyway. What is the negative exponent? What? Good. The negative exponent is equivalent as if he writes that the present value is equal to the future value. What did you say? Discounted, right? 1 plus the interest rate to the power of time. If instead of having it as a division, you put it as a multiplication, then you have that to the negative part. These two are equivalent. This is clear. Do you remember it from math? And we can go on and see it. Can I use this in chapter 4 and 5 that I'm talking about loans? Can I use this idea in chapter 4 and 5 that I'm talking about loans? What is a loan? What is a loan?
Inflow.
Your money you borrow. Why do you borrow money? To spend it. So Victor wants to borrow $5,000 so he can buy a nice diamond. And if he wants to borrow $5,000 to buy a nice diamond, I'm cleaning that up, and he doesn't have it, he goes to Yanni. And he says, in 3 years, I will pay you back this $5,000 that I get today. And I would like to pay you. I will pay you 1, 2, 3 years. But I would like to pay you not every year, but I would like to pay you every month. So every year, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 payments. So he has 3 years and 12 months every year. He's gonna make 36 payments. He needs to discuss what's going to happen with the interest rate that he's going to pay. If he's going to pay 5% for every year, which means from a year to a year, the change is going to be 5%. How much change is going to be from a month to a month? If from a year to a year the change is 5%, from a month to a month, how much is going to be the interest? What do we do? Here we have a multiplication, right? We know how many periods we have as something we multiply. If I want to do the rate from a month to a month, I need to do the opposite of multiplication. What is the opposite of multiplication? So it's division. He will take the 5% and he will divide it with how many months you will have. Which means if 5% is the rate for the year, the rate for the month is 5% divided by 12 months, that is in a year. And if he knows that, then Victor has to solve a problem. And that problem is simple to graph, but not easy to do it. That problem is, throughout all these years, Victor wants every month to have the same payment. But this particular payment is what he's going to pay. And he wants to pay exactly the same amount of money that he borrowed. Which means, in today's value, he needs to bring all the months in today's price, so he will know that it's going to be a fair deal. What do I need to do? I need to see what's the net present value. The net present value of the future payments is the payment that he has, PMT, discounted for 1 plus the rate. Which rate? The capital R or the lowercase r? The annual or the monthly rate? The monthly rate. And that would be for every period of time. But he has many periods of times. How many periods he has? 36. So he needs to sum up all these 36 periods of time. And that is how much he's going to pay. What he's going to pay for Yanni, that gave the loan, is a positive flow. For Victor, that he took the loan, is a negative, that he needs to pay it back. Here I have Yanni's point of view. Yanni's point of view says that he gets the payment. He gave the principal. And Yanni gave the principal and he gets the loan. What he has, this needs to be equal. Whatever he gave and whatever he got needs to be equal. Is this clear? Can we solve that problem? Can we solve that problem? If we want to solve that problem, what do we mean to do? What do we need to do? If I need to solve something, what do I need to do? Lina? I need to specify what I have here. So, what do I have here? 5% divided by 12. And what do I have here? I have 36 terms. And what do I have here? How much Victor borrowed? 5,000. Solving the problem means what? Everything is in numbers except of the payment. I need to put it and have a mathematical solution to that. Yeah, but this is a summation. This is a summation of 36 terms. Is it easy to do it? Or not? Okay. It's not that easy to do it. You can be able to use Excel, and you can have it done. So if I use Excel, and I have this case. You see what I want to do, right? Now I take this off, and I want to do it with Excel. And I ask your help. Can you come and do it? Yeah. What do you do? Let's make the graph. Let's make the graph. What do we have? We have a principal that is $5,000, right? This is $5,000. We take the principal. We have an annual rate that is 5%. I put it here. It's 5%. I give it plenty of decimal points. We want to know how many periods we have. We know how many years we have the loan. It's for 3 years. And we want to know how we would like to pay the loans. Victor wants to pay the loans monthly. We have 12 months in a year. We need to know how many periods we have. The periods are 12 multiplied by 3. And we need to know what is the rate for every month. The rate for every month is 5% divided by 12. The monthly rate is this one. And these are what we have for the loan. This is what we know. This is the known information. I mark it with green since I know it. I enlarge it. What I don't know is what is my payment. Can I find out what is the payment? Victor. Can I find out what is the payment? So now, can I find out what is the payment? How do I find out the payment? What do I do? I can't hear you.
Use the PMP formula.
So now I can't hear you, and I'm an old man. I use the
PMP formula.
payment function. I go to the formulas, I go to the financial formulas, I want to find out the payment formulas. I'm here at the payment formulas. And I don't know how to do it. So Sonali is going to come and put the information to do it. Go to my computer and put the information. The rest of you, I want you to do it before she has it done. And that's an important information because Victor needs to afford that amount every month. As he has it, Victor every month has to pay $1,800. And he says, come on man, shouldn't be right. I'm borrowing $3,000. Do I have to pay every month $1,800? So what do we have here? How many periods do we have?
36.
Good. Now, Sonali is having an answer, and Victor says, yes, every month I can pay $300. Click it. Is this right? Is this right? Okay, she thinks so. If this is right, go to your computer now. If this is right, we need to test it. First test is to see if we have the right information. And the information we have is the number of the periods, the rate for every period, the effective period, month, and the amount of the loan. It seems fine. So what Sonali is going to expect as a final grade? What's your expectation for a grade? She says A. She needs to be sure. If this is A, I need to make an analysis. I'll have one period, I'll have a second period. I need to go to as many periods I have to pay for the loan. I need to have 36 periods. Do I have 36 periods? If I have 36 periods, I need to see what is happening. What is going on here? The loan is 5,000. The loan is 5,000. The interest that Victor has to pay for that loan is 5,000 multiplied with the monthly rate. The monthly rate does not change. It stays as it is. I want to see what is this number. This number here is $20. And the payment that he has is fixed. The amount of money to repay the loan is how much is the payment minus how much he pays for interest. The remaining amount of the loan is 5,000 minus whatever he paid for the loan. Did I do things right or not? Is this correct? Few people gave that to me last time in the test. The remaining amount is from the loan minus whatever pays the principal, not whatever is here. So the column here should be D, this one. That means the second month, Victor has this particular amount. And if you do this, you are done. The next thing that you need to do is you take that information and you drag it all the way down. Before you go all the way, you test to see, is everything correct? Do you calculate the interest payment correctly? Yes, it's the rate multiplied by the amount of the loan that you have. That's correct. Do you pay the correct amount for the principal? That's correct. Is the principal the same? Yes, that's correct. It goes and takes whatever it is the payment. How much money do you carry for the next period? As much it was the loan minus what you take. That's correct. If this is the case, then you take it all the way to the end. If everything is correct, you expect at the end of the period to have everything paid, right? Did he finish the loan at that time? He goes up and says, okay, that would be done. All the periods are important, but what is the most important part is to go to look at the beginning and look at the end. And this is what he has. You want to look at the beginning and look at the end, and this is what he has. Yes? I will. But I don't want you to be late again. And then Victor goes on for diamond shopping. And he sees another diamond that is a little bit more expensive. And goes to Yanni and says, man, you're a rich professor. Can you give me more money? And Yanni says, yes. I'll give you $7,000. $7,000 as a loan. But since you want more money, I want more money. And Yanni now says that the interest rate is going to be half of a point higher. What is happening? Victor has to pay higher payment, and he has to pay more for interest. Therefore, given that situation, in the test I will ask you to tell me how much more money Victor pays for interest. In order to get a diamond that is from $5,000 to $7,000, $2,000 more, how much he needs to get for interest? Because Yanni, in order to give him more money, he wants also to get more money. And he increases the rate by half of a percentage annually. That means how much more Victor would pay for payment. And I want, on top of that, to double check your information. So what do we have? What do we have? I go here, and I take that information, and I want to see what is happening. That's the remaining of the principal. But the remaining of the principal also is here at different time periods. This is what you pay interest on the payment, and this is what you pay for the principal of the payment. And this is what is your payment. And I want you to double check your information. So what I want you to do is I want to calculate these numbers in different terms. Can you use Excel functions to calculate these numbers? Can you tell me where you find that in the book? Can you tell me where you find that in the book? My question in the test, in chapter 4, is if I want to calculate column C and column D using Excel functions, where do I need to open the book to find out that information? Can you tell me, can you open the book to tell me where you find out that information? I want to calculate this using the Excel functions. Can I do it? And I will go on, and I insert a column here, and I go on and I insert a column here. And I want to use an Excel function here. The formula is to calculate the interest on the payment, and the rate is here, the period is here, the number of the periods is here, and the present value of the payment is this one. And here I need a problem. I click it, and I have a number. I click it, and I have a number. I look at the two numbers and are the same. That means that the formula is correct, right? That means that the formula is correct. If the formula is correct, what do you do? Rudolin, what do you do if the formula is correct? Good. Did you hear what she said? The formula is not completely correct because I did not lock with $sign what stays the same. If I take it and I bring it down, here I don't get any information. The reason I don't get information is that here I take things that are completely different, proportionally being changed. That is not correct. That is not correct. I need to go and put $sign to what it is fixed. Can you go and do it? What is not changing? You go up here. You go up here. And whatever needs to change, you don't put a $sign before. But whatever does not need to change, you put a $sign. So the rate, it stays the same always. You put a $sign. The periods change. Is the first period, second period, third period, etc. You don't put anything. The number of the periods don't change. They need to be locked. The number of the periods need to be locked. She didn't lock them yet. The number of the periods need to be locked. Now, if we keep it the OK and we drag it down to the next cell, should be the same. Is it the same? That means that the formula is correct. Then we take all the formulas all the way up to the 36th period. And if we take it overall, we have the same calculation with Excel, same calculation with your stuff, and have it done. Is this clear? Same way she did it with this formula, I want her to do it with the principal payment formula. Or the principal payment formula can be done in a different way, as a subtraction between the payment and whatever she has for the payment on the interest, one way or the other. You have the payment, where is your payment? Column G. You have your payment, that's your payment, doesn't change. From whatever it does not change, you subtract the interest on the payment, column D, and you have enter, and this is what is happening. You take it and you bring it all the way down. You take it, you bring it all the way down, and as you bring it all the way down, it's a correct information. Is this clear? I'm going on now to what I said here. I'm going on now to whatever I said here. At a given point, Victor gets a lot of money. Let's go on and see what is happening now. Forget the numbers and the calculation. At a given point, Victor gets a lot of money. He gets a job, and he is not a student anymore to be dependent upon the payments. And at that particular point, after 2 years, Victor has money. And after 2 years, Victor does not want to pay interest for the next year. And as Victor does not want to pay interest for the next year, at that point wants to go to Yanni and asks a question. I want to pay everything that I owe you now. And I don't want to have loan anymore. How much Victor needs to pay there? I'm going to do the same thing this particular weekend. I'm going to go to AT&T and I'm going to tell them, some time ago my wife and my son got a phone. We pay that phone with installments. Now I want to pay fully for that particular loan and don't owe you anymore. And after I do that, I'll ask them the next question. And now unlock this phone so I can use it anywhere I want. Right? And this is my question for you. I want here to evaluate everything after 2 years, multiplied by the 20 months. At the 24th period, I need to evaluate what is happening with the future payments. At that particular period, what do I want to do? What do I need to bring back here? I need to bring up the payment. I need to bring up the interest on the payment. I need to bring up the principal of the payment or the entire payment. So far you follow me, right? So far everything that we did, you have it on your Excel, correct? I go here and I see what is happening. I take all these lines that I have and I reveal them. I have extra piece of information. I don't need them because these are exactly the same. I take the information that I have. 1 year is passing. 1 year is passing. That's the first year. I mark it. Second year is passing. I mark it. Mark the second year. After that particular year, I want to go on and see what is happening. After that year, this is the amount that I owe to Yanni, right? Right, Victor?
Yes, sir.
Would you pay him this amount? Or you want to pay him less?
Yes.
And why? You want to pay him less?
You don't want to pay the interest from the remaining.
Correct. And when you go on to negotiate, you don't want to pay the interest on that particular amount. What do you want to pay?
Just the principal.
You want to pay the principal. In other words, what do you want to do? How to calculate it? And this is my question for the test. This is my question for the test. And this is something that it is in your book. You can find it in the book. Actually, what you will find in the book is a more interesting case. The book says you borrow money to buy a house. But as you borrow money to buy a house, after some time, interest rates get lower. And then if the interest rates get lower, you want to change that particular loan from whatever you have with higher interest rate to whatever is now with lower interest rate. But if the case is exactly the opposite, you buy the house with very low interest rate and the interest rates are going up, you don't want to change the terms of the loan with the higher interest rates, you want to lock it there. Is this clear? And this is a practical case scenario. And I want you to be able to go and argue. Because if you go to Yanni, Yanni may say, okay, you owe me $2,462.48. Forget the $62 and the 48 cents. Give me $2,400 and we are done. Do you take it or not? And why some people would say, okay, here is your money, and Victor would say, hold down, man. I don't want to pay this amount for interest. Victor said, I don't want to pay this amount for interest. Right? Is this a lot of money? Is this a lot of money? This is what actually Victor says that he doesn't want to pay. And Yanni says here, okay, let's make everything rounded. give me 2,400 and we are fine. Give me 2,400 and we are fine. Would Victor agree with Yanni, or Victor would go to the rule and say, no,
No.
I want not to pay the interest? And in one way or the other, someone may lose and someone may gain. And who is losing and who is gaining? Or in other words, the difference between these two is $62. Is this monthly payments for interest in present value for the beginning of the period, more or less than $62?
More,
Hmm? How much?
like $9.
What do I want you to do is I want you to calculate,
I did.
I want to calculate at that point, the present value at that point of these future interest payments. Do you know how to do it? Yes, page 42 said if you have periods of time, you can be able to do two things. You can be able to discount and go back, and you can be able to appreciate and go forward. What did I ask you to do? I want you to know what is a net present value. Net present value means that you discount this information here. For how many periods? You need to discount this information here. For how many periods? I take this. I take this from here and I copy it. I bring them here and I paste them. And as I paste them, I know how I will do it. I paste them for the next. I paste them for the next 12 months. What do I want to do? I want to find out how much is $11 in 1 plus the monthly rate for the period of time that is for 1 year. That's $11. That's $11. I want to take this information and see how much is $10 right now. This is what is $10.37 in a year. I take everything for that particular period. That's the present value of these flows. What is a present value? A summation of what? Of all of that period. And I have it here. The present value, this is how much? $72. What's the difference? Yanni said
$10.
it's the difference is $10. What's the importance of the principle? The importance of the principle is if Victor was not dealing with 7,000, but was dealing with 70,000. If he was dealing with 70,000, then the amount of money would be completely different. If the rate was not 5.5%, but if the rate was 1.25%, that would be completely different. If the time is different, it would be a significant difference, and this is the idea that you get. What is the idea? Whenever you get loans, as you move on in the loan, you make decisions. One of the decisions is to refinance the loan. Refinancing means from a given point and after, you have a different rate. When this is rational to do it, when the rates go down. Second case, when you don't refinance the loan, but you want to pay back the loan at a given point of time. I bought a house, I worked hard, I made money. I didn't want to keep having house as mortgaged. I want the house to belong to me. I went to the bank and I negotiated so I will pay that. At that time, the bank said, okay, we will do it. We'll take your calculations, but we'll charge you a fee of X amount of money. And I had to figure out, is it worth it for me to do it paying the fee, or it's not worth it not to pay the fee and let the house be in a mortgage? I have another case that is not in the book either. Can I take the loan and make decisions with respect to timing? In other words, I get a loan for 20 years. After the 10 years, I want to renegotiate, and I want to pay the remaining amount of the loan, not in the next 10 years, but in the next 7 years. Shorten the time, which means I can pay more. Or do exactly the opposite. After the 10th year, I want to extend the time of the loan for 3, 4, 5 more years. Or I can change the interest on the loan. Or I can do any combination of the above. What do we want to do? Usually we want to take the advantage of lower rates. What do we want to do? Usually we want to play with the timing of the loan. When do we do that? My friend had a mortgage. He paid the mortgage and his son finished his dental school. He wanted to go and become an orthodontist. And he looked at the case. One option was to take the student loan. The other option was to remortgage the house for 5 more years. And he had to make a choice. What is better for him, to take a student loan or to remortgage the house for the other 5 years? And he had to do his calculations. And this is what I want you to go through the book and see what is happening so we can move on in that case. Is everything clear so far? Okay, Lena, what's the question?
Could you show the last part again where you, for the last 12 months, the summation or whatever you can say?
Good. I go here for the last months.
Yes.
So what is happening? Up to the 24th month, the end of the second year, I was paying things normally. After that particular period, I have this total amount of the principal to be paid. At that point, Victor wanted to pay back the loan. And let's make the numbers not large, but small. Let's go on and talk about the original case. The original case was that he had a loan for 5,000, and the annual rate was 5%. On this case, we go back, and he had remaining amount of the loan, $1,750.48. And the question is what Victor wanted to pay. What Victor wanted to pay.
Numbers change a little bit.
Yeah. The numbers changed a little bit. Why the numbers
Yeah,
changed?
but it is
Victor, why the numbers changed? Because we changed the hypothesis. What was the hypothesis? The hypothesis was at the beginning, you had a loan for 5,000. Then you made the change to get a loan for 7,000. Why? Because you wanted to buy a little bit larger diamond.
it was 5.5 in this example.
And Yanni said, okay, I'll give you more money, but I want more money too. And he changed the rate for 5.5%. That's why you use Excel. That's why you don't use financial calculators, because if you use Excel, you change whatever you have a hypothesis here, and everything is different at that particular case. Now the numbers are different, and I want you to be familiar with that difference of the numbers. Now instead of talking about 1,700, you're talking about $2,400. And the question is, in that case, what Victor does not want to pay. And Victor says, I'm giving you the money now. I don't want to pay that extra interest because you get the money now. So what Victor does not want to pay, Victor does not want to pay the present value. Victor does not want to pay the present value of the future interest payments. What he calculates how much is the present value of the future payments that go for the interest. And he says, since I'm paying you now, why I should pay you all that interest? And Yanni agrees. But Yanni says, okay, let's round up what is happening. And Yanni is interested to give away, instead of this, 2,400s. Victor does the calculation. And Victor calculates that if he had to gain, he had to pay less, $72 less. But Yanni gives him $62. By Victor agreeing on that case, what he does?
You lose $10.
Or he gives $10 to Yanni to have that deal. Is this clear? Lina?
Yeah, so but I'm not sure the 72.41, that's just the summation of the,
Correct.
okay.
That's why you use Excel. When you use Excel, you go on and you find out what is this amount of money.
Okay.
This amount of money is the present value of the future interest payments. And this is what he needs to pay. What he actually, Victor, wants to pay here. Is any other way that we can calculate what Victor wants to pay here? Is any other way we can calculate what Victor wants to pay here? Woodland would say something else. Say, okay, take this on the side and let's calculate the present value of the payments on the principal. Calculate the present value of the payments on the principal. This is fixed, and this information here is whatever is the principal payment. Goodwin now makes another proposal. I want to pay this amount. What is this amount here? This amount is what I would pay in a month from now today. This is what I would like to pay. Is this right information or wrong? Is this right or wrong? Is this right or wrong? And Woodland says, I'm going to sum up that information here. And now she has something different here. Woodland suggests to Yanni, or to Victor actually, that Victor should not pay $2,400, but pay $2,390. Is this the same or not? Let's see. If you take this number, and if you take this number, what is the number? Oh, I want you to start seeing exactly what is the number. Now, Woodland gives me an explanation. What is the number that Victor pays? Victor pays the present value of the future payments for the interest. Is this clear? Which means I want here to make a loop. I want to go back to whatever is in chapter 2 and relate chapter 2 to chapter 4. Because actually chapter 2 and chapter 4 is the same stuff. It's present value, future value, how they are related. Do I want to put chapter 3 into the process? Yes, I do. What is in chapter 3? In chapter 3 is another concept. The concept of internal rate of return. And I want you to be comfortable with that process. What is the internal rate of return? What is the internal rate of return? What time do we need to get out of the class? 5 minutes. Okay, what is the internal rate of return?
You want to read it from the book?
I don't want you to read it from the book. I don't want you to look at the book. I want you to know it from the book and put it in your brain, and after that remember it in your brain. What's the internal rate of return? Vanessa, what's the internal rate of return? Did I ask you in the previous test what is the internal rate of return? Yes or no? Did I ask you? In your previous test, did I ask you about the internal rate of return? Okay, if let's say that you get an A in the test and you don't remember it, what's the value of that A? Nothing. Right? I want you to know what's the internal rate of return. What's the internal rate of return? Vanessa? What's the internal rate of return? What's the internal rate of return? What interest rate? What's the internal rate of return? Woodland, what's the internal rate of return? Okay, what's the internal rate of return? I didn't get any answer from the women. If I didn't get any answer of the women, what's the choice of get something from the men? Almost not, correct? What's the internal rate of return? Victor?
It's the present value that sets.
No. The internal rate of return is the rate that makes the present value equal to 0. Which means what?
It's a fair.
No, it's not the fair number. The internal rate of return is the rate that makes whatever I pay and whatever I get in today's value, in present value, is equal, which means that the loan is fair. This is the internal rate of return. And I want to use that particular concept, the internal rate of return concept, in my loans. Because if I know this is what I give and this is what I take, this is what I get as a loan and this is what I pay for the loan, and in present value these two are equal, the internal rate of return says what is the rate that whatever I will pay in the future is equal to what I get right now. Is this clear? Okay. Go to chapter 5. Do we use the internal rate of return in chapter 5? In chapter 4, we do things in terms of finding out how to evaluate the different loans and how to negotiate. In chapter 5, do we use the internal rate of return?